Homework pressure? No more. At Spring Library, we explain every topic in simple way. Join the learning family and score high every day.
So part A here has us analyzing a Volkswagen that is starting from rest, which means its initial velocity is 0 meters per second, and it is speeding up to 60 miles per hour with an acceleration of 2.35 meters per second squared. Now you'll notice I did not write down the 60 miles an hour, and that's because miles per hour is not what we actually want to be working in, because we're dealing with base units, so we want to take miles per hour and convert it into meters per second. So the conversion factor here, that's a really good one to keep in mind, is that 0.447 meters per second is equivalent to 1 mile per hour. So if you're in miles per hour and you want to convert it into meters per second, you simply multiply your value by 0.447 meters per second here. 0.447, and that in this case will give us our answer of 26.82 meters per second. So that's what I'm actually going to record over here for my information, because if everything in my information is using base units, then I'm good to go ahead and plug in my numbers. Now, this problem wants to know the time it takes for this Volkswagen to get up to its full speed. So that means I'm looking for this t value here. Now, for any of these kinematic problems, you always need to know three numbers, which we do from the setup. There needs to be one thing you're looking for, in this case it's t, and one number that we do not know and also do not care to know, which is the x value here. And that means our equation that we're going to use is the one that does not have an x in it. So we can cross off these bottom three, and we are working with this top equation that v equals v naught plus at. Now I'm going to take a second and rearrange this because I want to know what my time is. So before I plug in any numbers, I'm going to sort this and solve it for the fact that time is the v minus v naught, our change in velocity, divided by acceleration. When I plug in my numbers here, we end up with 26.82 minus 0 divided by 2.35, which gives us a final time of 11.4 seconds. So that's how long it takes this VW to get up to speed. Now, the second problem has the same kind of initial piece. We have a car going from 0 meters per second, from 0 meters per second up to 60 miles an hour, or just like it was before, 26.82 meters per second. But this time, I want to know how fast the sports car, or what the acceleration for the sports car would have to be if it gets to that speed in 0.6 seconds. So if it can get all the way up to 60 in about half of a second. Now, in this case, we are looking for the acceleration. So again, I'm using my equation that does not have an x in it. So we have v equals v naught plus at. Only this time when I rearrange it, instead of rearranging it for time, I'm going to rearrange it for acceleration. And that gives me 26.82 minus 0 divided by 0.6 for an acceleration of 44.7 meters per second squared.